Hello everyone. Myself Mrs. M. Archana, Assistant Professor in the Department of Pharmaceutical Chemistry and Analysis. So today I am going to discuss about the solid phase extraction. This is in the subject of modern bioanalytical techniques, which is for the M.Pharm analysis students studying in the second sem. So let's look into the topic. So what is this? What is meant by solid phase extraction and what exactly it will do? So solid phase extraction, normally it's a common thing, like a common column chromatography you can say it as, but it's a wonderful technique. So it will bridge a gap between this sample collection and analysis. Normally if we take any biological sample, there will be a lot of matrices involved, so there are a lot of interferences are there. So this is one kind of extraction technique which will help us to target our analyte and extract it with a full concentration range. So apart from this, sometimes we can avoid certain pre-treatment of the sample techniques like filtration, homogenization, precipitation, etc., which are all given here. So that is one of the major benefits of the solid phase extraction. So, and it helps to the steps involved in this technique helps us to get the fullest concentration of the analyte as well as to purify it. So like solid phase extraction is majorly used in the sample preparation steps, such as when you want to adjust the pH, when you want to dilute it, or when you want to purify it, separate the components of the sample matrix, then this technique is majorly used. So however, this performing SPE, it needs it has to be completed with other preparation goals also. We cannot depend completely on this technique alone. That is what this SPE is. So we can avoid a few techniques of sample preparation or pre-treatment of the sample. Apart from this, for our analytical purpose, this will help us to extract the analyte of our interest, and we can easily quantify them. So there are like 4 steps involved in this technique, so which I have given here in a video. So if you see solid phase extraction technique, so first step is conditioning, second step is equilibration, third step is loading, fourth step is washing, and fifth is elution. So what are the basic steps of solid phase extraction is? So in this we can say that liquid extraction is also one of the significant starting point in the interpretation of SPE. Why? Why it is a significant step means because sample is agitated, that means it will be prepared or mixed in the presence of an extracting solvent. So it is an immiscible solvent. So this solvent will be used as an extraction solvent. That's why it is also a significant interpretation for liquid extraction also. So apart from that, when sample solvent mixture settles, one layer should contain most analyte. It's like a partition effect of the solvent, because whichever the solvent gives a very good environment to the analyte, it will shift towards that particular solvent. So that's why it is a kind of partition between two solvents, and that's why LLE is also one of the significant role in SPE. So that's why how equilibrium will be attained. So high partition coefficient means all compounds migrated to the extractant. Low coefficient means all the compound moves into the very little they move into our extractant. So based on this we can identify which environment is suitable for our analyte to move into this. So for this to achieve this we need to find out what is the exact extracting solvent, favorable extracting solvent, and we can maximize the partition coefficient easily. So this can happen only if the extracting solvent is very much compatible with the analyte and it provides the environment properly. So only the selection of this extraction solvent is very important. That is also a equilibration step. So next stages of after this equilibration we have to load the sample and there will be a point of retention. So this retention can happen in two types, two ways. One is simple adsorption, which we know already in the chromatography we may have seen, or some of the penetration of molecules into the outer layer of the surface. So some certain molecules enter into outer layer of the surface. That is one more thing. So equilibrium is also similar to liquid extraction, because as I said we need one extracting solvent for the extraction purpose. So this extracting solvent should provide a very good environment for the analyte to move into it. So when it moves the partition coefficient increases, when it doesn't move the partition coefficient decreases. That means nothing but a simple distribution of the analyte between the two layers of the liquid. So that's why that's how we can achieve the equilibrium after using an extraction solvent, and the analyte will be distributed between the liquid phase and solid surface. So when the analyte is distributed, it will be retented on the solid surface based on simple adsorption or based on penetration of molecules into the outer layer of the surface. So it's an integrated part of LLE as well as the SBE. So if you are packing a column with a sorbent material, so it is no longer like a partition with LLE. So it's a mixed up of SPA and LLE. So normally if you are packing completely with a material, we cannot say it is LLE. Or if you are using a inner sorbent material and coating a liquid layer on the top of it, then we can say it is a LLE as well as the part SPA. So here the distillation equation will be converted into Kd, analyte by sorbent, analyte in the sample, which is nothing but how it is getting distributed between the sorbent and the actual volume of the analyte. So V0, VR nothing but void volume, retention volume. So if analyte is entirely trapped on the solid surface, as we know, distribution coefficient will be higher. So chromatographic extraction, this is elution chromatography, is best described as a pseudo-equilibrium process. So because the analyte will be completely adsorbed on the solid surface. So most of the solid phase extractions requires a liquid sample, so that we know, and passed on to the sorbent particles onto which the analyte will be retained. So it is a simple technique of identification, separation and finding out the distribution of the particular analyte in the sorbent material. Okay, so during this retention step, many compounds in the complex may have been retained on the solid surface at the same time as compound of interest. Yes, this is a complex matrix, so many have been retained on the surface apart from the analytes. So elution plays a major role in the getting out desorption of the analyte from the solid surface. So to minimize the undesirable compounds elution, we have to make it as more number of washing steps should be done, so that we can get the complete pure analyte concentration of our target. So this has to be done carefully. So we have to select the solvent of washing and how many washes we have to do, and how you are loading the sample all depends on this technique. So what we have to do is, as we understood that already, if distribution based on distribution coefficient, if a liquid layer is providing more comfort nature to the analyte, it will get move towards that particular environment. So such kind of criteria and all we have to we have to consider, and we have to select the solvents. So coming to the complete solid phase extraction and not including the LLE. So one can select, first of all, what is the importance of this is we can have to select a sorbent material, that is solid phase, and we can manipulate its chemical nature so that to increase the retention time, and we can select the sorbent material based on the analyte properties also so that it can be retented more. Okay, so after that we can also finalize how many washing step is needed based on that particular sorbent material also. So that is one complete solid phase extraction where any liquid or partition is not involved. So this is one example. So if you see sample matrix, how it will look like, and after washing, elution, you can see the differentiation, how they are getting dissolved and getting eluted. So retention time, retention means already the sample has been loaded, and we can see the analytes and the impurities or other matrices got retented on the surface of the solid material, which such as the retention picture. Then after washing, during the washing stages, one analyte, analyte impurities or other interferences which are having their based on their retention properties, they are eluting, getting eluted. So after collection of this elute, we will be further analyzing them. So this step of washing is called elution, which you can see in the three pictures. So what is our goal in the SPE is majorly to find out the concentration of our analyte, and we have to clean up, we have to remove all the unwanted molecules from the sample, and we have to any sample matrix solvent exchange is happening, that we have to completely avoid it. So these are the three types of goals we are having: concentration, cleanup, and sample matrix solvent exchange. So first one is the objectives of SPE is concentration. So concentration, let me show you a picture. Here we can see different large sample size as well as the smaller sample sizes, and after processing of the larger sample through large SPE device as well as small SPE device, we can see the differentiation here. So large SPE device, we have Rotok concentration, Karna Danish concentration, evaporation under nitrogen stream. These are like common ways for the enhancing the concentration of analyte in extraction procedure. So further, we can also to achieve this adequate concentration in the SPE step. So we cannot we no need to minimize any sample size. Okay, so in the solid phase extraction, you can have higher pools of sample size, and you can easily extract it. Easily extract the sample matrices, be it a smaller size or be it is a larger size. So that is one benefit of this, and we can acquire the fullest concentration of the analyte. So we have to understand, in order to optimize this extraction procedure, we need to understand certain things. One is capacity of our solid phase sorbent. So what is its exact retention capacity, and what is its pH, ionic strength, etc. So these will help us to select our sorbent material, and we can use it for the proper retention of the analyte. So that one important step is selection of solvent to optimize our process. So concentration of an analyte is pointless if it cannot be measured in a final concentration solution. So if you cannot measure in a final concentration solution, this step is not required. So most of the extracted sample contains interfering compounds. So we have to correctly understand what is the exact concentration of analyte and concentration of these interferences. So if they co-elute, we have to easily identify them. So that's why we are washing repeatedly, and we are collecting this matrices and identifying them. So sample preparation helps us to remove such interferences before our analytical step. So cleanup is very important, which is our second step of our goal or objective. So with the cleanup step only, we can easily remove the interferences with the repeated washings of the sample. So this cleanup is can be achieved either by retaining analyte on the solid phase or washing out interferences or by retaining interferences or washing out the analyte. So either way we can perform this cleanup and we can collect our analyte of our target with highest concentration. So this is how it looks like, the chromatogram. So first one is before cleanup, next one is after cleanup. So we can see the complete difference. In the first diagram we can see the interferences are more as it is not cleaned up. In the second one after cleanup you can see the peaks properly of the analyte. So sample matrix removal, our third goal. So many analytical instruments they require sample to be analyzed in one particular environment. That is, we have to inject aqueous sample onto the GC. So this will easily ruin the instrument. So injection of aqueous sample into GC is not at all a good one. It completely deteriorates the instrument. So what to say? So this kind of techniques is not suitable because what to say, they need a specific environment. So whether a sample is a blood, urine, face cream or anything, it has to be converted into a compatible sample for the instrument. So the instrument has to take the sample properly without any deterioration or damage to the instrument. So we have to completely prepare the sample in such a way so that the instrument is also compatible. So if we see SPE or LLE, what is its advantage is the sample matrix which we are preparing for the analysis, they can be easily miscible with the different kinds of solvents, and these solvents are very friendly in nature with the instrument, so we can easily analyze our samples. That is one benefit. So some examples are given here. So constraints during SPE. So three aspects of sample preparation using this procedure is represented in one diagram in the next slide. So that diagram explains about achieving all three goals, that is cleanup, concentration, efficient matrix removal in one simple SPE extraction. So however, sometimes we have to compromise. So why we have to compromise means, so optimum sorbent that will give excellent retention or excellent elution for one specific analyte. So sometimes it will be difficult to elute certain mixed analytes or more than one analyte. And next, if we try to extract more than one analyte at a time, so for example they have given drinking water for a range of environmental pollutions, so one sorbent will be best and another may not be suitable for the extraction. That is another problem. Wide range of analytes. So here what happens, the elution will become poor because of the wider range of analytes available in the sample. That is another problem. Next explanation is, if we consider the process of retention and elution, that is also one problem. So you can see here in the triangle diagram, analyte, sorbent, matrix. So analyte, so matrix to analyte we use the mechanism of extraction. So from the analyte to sorbent recovery as well as concentration removal, it's kind of like difficult. So this diagram tells us about how to select a ideal choice of sorbent for recovery, for maximizing the concentration, so that it has to be compatible with the sample type. Otherwise we cannot achieve that. So we have to achieve the good concentration, large volume of sample is required. We have to pass it through the solvent, that's we know already. And if there are any interactions which are higher in range, the elution will not be easy. So large desired volume of elution solvent is also required. Okay, so to avoid this kind of problems, based on the polarity, we will be selecting different range of sorbents and different range of solvents, which will help us to avoid large volume of sample injection as well as large volume of solvents usage for the extraction purpose. So that has been given here. These are the sorbents and their acronyms. Primary, what is its polarity, nature, based on that it has been listed. So these are very much useful in case of solid phase extraction. There are bonded phases, unbonded phases. So these are very important, especially if we are using for the SPE extraction. So these are the topics I want to discuss about the SPE. So we have discussed about what is meant by solid phase extraction, what are the different steps involved in that, and what are the three different goals that is the target of our SPE, and what are the constraints we can face during the solid phase extraction procedure. Hope this video is useful for you. Thank you.